And this is the last talk for this session, okay?
Okay, great. Thanks for having me. It's always fun to be here. I love JuliaCon. I'm going to talk about Queryverse. I think I forgot the precise title that I submitted, but I think it was promising something like Going Deep. But here, this is the URL for Queryverse. So if you want to take a look what it is, just go there. And then here's my outline for this talk. I will first start out with a brief overview. What is Queryverse? Because I assume there are some folks in here who who are not familiar with that. Then I will give a bit of a pitch what we did over the last year. Some of you might have been at JuliaCon last year. I gave a long workshop on Queryverse, and so I'll give a brief update, the delta between whatever I showed in London last year and where we are today. And then I'm actually going to the topic that I promised, where I will dive into some of the aspects of the design of Queryverse, and then I will finish with some of the ideas that I hope to, that doesn't have to be me actually, where I hope that we can go with Queryverse, and maybe some of you would actually want to help out with that. So what is it? So broadly speaking, it's a family of packages for data science. It's started with the query package, but by now it's a family of packages. They're tightly integrated with each other, so you get a really nice, consistent environment, but they're also tightly integrated with the whole rest of the Julia data stack. So I think they currently, pretty much any package should work with any other of the data packages that are around. They're generally, everything I do there, I consider stable and ready for production use. So I don't break things on purpose, but sometimes I make bugs, but then that's sort of an accident. But the core design of Queryverse has been stable for 2 years. It's worked out well. So what we've been doing is adding stuff, but not redesigning things. And I see no big redesigns, or any redesigns actually, coming. So if you want some stability in your data stack, then the packages that make up Queryverse, I think, are a good bet. So to give you an overview over some of the features that we have in Queryverse, I wrote down a sort of typical Queryverse exercise. You might load some data here from CSV file. You pipe that into a query operator where you select a couple of columns from that data. You add a new, you change the values in one column by some computation here. You group by 2 columns the results, and then you exercise a computation for each group that you had, and then you might save the whole thing out into a CSV file. So that's sort of roughly the structure of a typical query. And I've grouped them into sort of the source of your query. That's what you start with. The data manipulation, that's all this parted here in the middle, and then what you do at the end with your query results. And these parts here, the beginning and the end, you can swap out almost anything. So you don't have to start with a CSV file, and you don't have to end with a CSV file. You can start and end with many different things. So here are the things you can start with. In terms of file I/O, Queryverse has, I think, 4 or 5 file I/O packages. And you can load any of these file formats here with the same syntax. You just say load, file name, and then you can start your query. And so that works for Feather files, Parquet files, Excel files, old and new style, and then a whole bunch of statistical software packages. So all of those are integrated. You can start with an existing data structure. So you can start with a data frame, with an index tables, with a JuliaDB thing, with a typed table, with pandas, time series, temporal. I think this covers pretty much any of the table structures that we have right now in Queryverse, and you should be able to start with any of these and then query them. And in fact, you don't have to start with a tabular source at all. Query is actually quite agnostic when it comes, so it's not about tables actually, which is a bit counterintuitive, but we'll dig into that a little bit later. You can actually just start with any iterable, okay? So you can start with a sequence of numbers and query that. Or you can start with a dict. A dict is a sequence of pairs, and you can start to query a sequence of pairs. So that works. Any TableTraits source, which is sort of the tables interface that is native to Queryverse, works. I think almost all tables sources work as long as they add 2 methods, then they should easily hook into that. So essentially, I think at this point you can say you can query almost anything in Julia data space. This is the manipulation part, and we have two different syntaxes, front-end syntaxes in Query for that. You could either use the link style, which I'm not showing here, or the standalone style that I'm showing here that is sort of based on these pipes that you pipe things from one operator into the next. It's clearly inspired by dplyr. I currently like that style better, but the link style is not going away because I don't break things, right? So that will stay around. The kind of operations you can do is this one here. So the typical things you might know from SQL. It's actually a richer set of query operators. All of this comes from LINQ, the C# design, which is in some sense a superset of a relational query language. And as I already pointed out, the core design of this middle part, the manipulation part, is really not about tables. It just happens to also work well for tables. Okay, so that's, if there's one thing you take away from this talk, that's actually what I want you to take away. Okay, then sinks at the end. What can you do with, where can you pipe things in at the end? You can do file I/O, so you can save things as feather files, as CSV files, as Excel files. You can materialize a query into any of these table types. So you can materialize this into a data frame, into an index table, a JuliaDB, any of those work. It's integrated with, well, it has working integrations with these two plotting packages right now. VigaLite is the native plotting package in Queryverse, but it also works with stats plots. We used to have integration with Gatfly. It's broken right now, but we'll try to fix that again. You can directly use a query as the input into a regression with GLM, for example, because it's integrated with stats models. There are lots of interactive UI tools that can consume the output of a query, so all of these here work. So really, in terms of interfaces, anything that can consume an iterator can consume a query. Okay, that's sort of the broad story. That includes any TableTraits sync, and it includes any table sync. So any package that implements one of these two will be able to consume a query. So it's deeply integrated with really the whole Julia data ecosystem. All right, let me briefly talk. And if you want to have a deeper dive introduction into how you use all of that, I encourage you to watch my tutorial from last year. It should be online on YouTube. It's endless. Because I don't break anything, everything I show there is actually still working today. All right, what's new in Queryverse? What have we done since last summer? A fair bit. So in terms of file I/O, I've done a lot of work on improving CSV files performance. I've created a benchmark suite that compares lots of Julia CSV file reading packages and then the R and Pandas packages. So performance here is great. I think at this point I would say CSV files and CSV are very similar in terms of performance. So for one cases, one package wins, for another a different one wins. So I think that at this point is pretty similar. Excel files got write support. That is new. In terms of work in progress, where we actually have started writing code, is we are going to add write support for all the statistical files. We can already do that with float columns. We just need to add support for some other data types, but that is coming. And then we're trying to change how the Excel files story right now relies on a Python package. We're trying to drop the dependency on the Python package because installing Python always can go wrong, and we have a strategy of how we think we can get rid of that dependency and get still be able to read and write all types of Excel files. So that's what we have in file I/O. There's a lot new in VigaLite, the plotting package that is native to Queryverse. The first important thing is I think the deployment issues that we had on Windows and Mac are gone. That has been a pain point, but I think we got rid of it. There might still be something on Linux, but if you're on Linux, you're a geek, so you have to figure it out. And then one great thing about VigaLite is that the package just wraps a really rich JavaScript library that is developed by a fantastic team that is quite large. And so I don't have to do anything, and I get new features for the package, which is awesome. So some of the new things is we got facet wrap and wrapped concat and repeat. We got new mark types, so you can do box plots, arrow bars, and arrow bands. And then there's just an endless list of small tweaks and improvements that we all benefit from that happened in the underlying JavaScript library. So I think this is just a really mature plotting library for in the ggplot grammar of graphics type style. In terms of interactive UI stuff, we have a whole bunch of new stuff. There's one package called Electron Display. It's a data UI for the REPL, so if you don't use any of the IDEs, but you work in the REPL, then this is a package that you can load, and it can show plots, lots of them, not just VigaLite, but I think most of the plotting packages that we have can use that, and it can also show tables in a grid with a nice UI. Some of you might know I also maintain the VS Code extension, awesome Julia editor, and we added the ability to show, so VS Code always had a plot pane in the editor, but we also added a feature now that it has a grid view so that it can show any tabular data in VS Code. So you see that here, right? So there's a viewing for that. One thing I want to give a pitch to, there's nothing new here, but I still want you to check it out. Data Voyager, it's an interactive UI tool to interactively explore data sets in a visual way and create VigaLite plots. It's awesome. And I just, check it out. I think it's not getting enough attention right now. Okay, we have a whole bunch of new things in terms of Jupyter integration. I don't know how many of you know Interact. It's an alternative Jupyter front end. It is actually really nice. It has native table rendering and native VigaLite rendering. So what that actually means is if you run a query in that kind of notebook, and it turns out a table, then the table actually shows in a tabular grid, and you automatically get buttons to start visualizations based off that table and so on. And so anything in Queryverse, any of the CSV file IO packages, any of the query operators, if you end with any of those here and you view that, then we integrate with this grid here in Interact. I think actually that Jupyter Lab is working on providing the same type of integration, so I would expect that at some point just starts to work in Jupyter Lab as well once Jupyter Lab has that integration ready. We have a whole bunch of new query operators. One is unique. It's very simple. You start with some sequence of values. You call the unique operator. You collect, and it filtered out any duplicate values. And then what we've added is 3 new query operators that are table only. So I started out by telling you query is not about tables. Well, okay, so now we caved. So I've added 3 query operators that only work with tables now. They're all dplyr inspired. One of them is select, so you can select columns. You can do that by name. You can negate, take columns out. You can do some string matching, and you can use ranges for that. There's a rename operator to rename columns. And then there's a mutate operator that allows you to mutate only specific columns in your data story, and that is often a little bit easier than to do a full map over a story. So those are shipping. Then we have a new story, and I'm here just featuring Brandon Taylor. Some of you might have seen his light query talk yesterday. Brandon is a Google Summer of Code student this summer. He's fantastic and awesome. And he started working on a SQL backend for the query language. And so what does that do is the following. So let's say you have a SQLite database. You start out by creating a database connection here. And then you can say, this is the database, dot the table name. And then you write a standard query in the same way that you wrote it previously. But what happens now is that this query actually, when you execute it, it gets translated into SQL. The SQL gets sent to the database. The SQL is running in the database, and it's only materializing the data that comes out of that SQL query. So that's much more efficient than loading everything into main memory and then processing in main memory. And so I'm really excited about that. It's sort of one thing I wanted to have in Query for a very, very long time, and I never got enough motivation to start it, and Brandon is doing awesome work here. What I like especially is that I always had a strategy for how this could be implemented. Brandon came in, a week in, he said, that's not a good strategy, I have a way better idea, and he was right. So all my planning was for naught, but he did an awesome job. And I think this so we have a prototype version that works for a whole bunch of query operators. We're not completely done, but it's certainly beyond the vaporware stage at this point. I think I'm going to, I'm playing with a very simple table type. It's experimental, so maybe that's sort of not so important today. Okay, so that is what we have, what is Queryverse and what's new in Queryverse. So now I want to dive a little bit deeper into how does it work? What's the underlying, what's the deep dive here, I guess. So let's start out with the structure of a query. So this is a typical query. You start with a source, you apply a filter, you apply a map, and you have a data frame, and you use the pipe operator to pipe things through this pipeline. This is what I call the standalone front-end syntax. You could write the same query in the link style syntax, which is just an alternative syntax. So both of these are supported by query. And you would write it like this. It looks a little bit more like SQL, but it does the same thing. Both of these forms under the hood get translated into essentially this story here. So you start out with your source. You pass that to a function called filter, where the first argument is the source. And then the second argument is an anonymous function that is the filter condition. The return of that you pass to a function called map. So the first argument here is the source. You pass as the second argument an anonymous function that is the projection that you want to apply here. And then the return of that you pass to data frame. So this is actually, if we think about front end and back end of Link, this is sort of how it always ends up coming to the back end. Okay? So these are just different ways to construct these queries. I should say one caveat here. I'm in the rest of the talk, I'm going to do certain simplifications because I don't want to talk about certain aspects of query. So not everything I'm showing here is 100% accurate, but in spirit it is. Okay, so how would you implement this now, right? So let's actually start with a bit of a weird case that I would not recommend. But you could imagine that source is your own data type, right, that I don't know about and that happens to not be an iterator, so it's sort of completely custom. And so you want to write a custom backend so that you can use the query front-end syntax so that it queries your custom type here. So how would you do that? Well, so let's say source is of type foo. You can add a method to the filter function that dispatches on this first type foo, and it might return a filtered foo type. So now that filtered foo type is going to be passed to the map function. You can add a method to map that dispatches on filtered foo, and that might return a mapped foo. And then at the end, you might add a method to the data frame constructor that takes a mapped foo and processes that. So in that sense, one way to enable a backend to integrate with the query front-end syntax is just to add methods to these query operator functions that conform with the method signature that I prescribe and dispatch on the first part. Okay, so you could do it that way. That would be a lot of work, and that's sort of obviously not the recommended way to do it. I think the only person that's doing that right now is Brandon with the SQL backend, right? So that's essentially what he's doing. But the default here is that for each of these query operators, for filter, map, and all the other ones, there's a default implementation that just works with any iterator as a source. Okay, so that's sort of there's actually no signature, but you can pass it any iterator, and it will return an iterator. Okay, and so that's a simple design, but I think it's actually the core brilliant idea that that was sort of powering Link. That these query operators take an iterator and return an iterator. And that's the only structure you impose, nothing else. So why is that so great? It's so great because it allows you to compose things in a crazy way. So because if every query operator always accepts any iterator and always returns an iterator, then I can guarantee you that I can compose the output of any query operator as the input with any of the other query operators, because they will guaranteed return an iterator, and they can all deal with iterators. So I have nothing like, oh, this is a query operator that only works with a grouped table or something like that. That's not how it is designed. The story here is that every query operator can be combined with any other query operator because the link is always purely an iterable. So this was the example that I mentioned here. So there's a caveat to that. This every here is a lie. There are some query operators that actually do not return an iterator. So there are query operators, for example, that count things. But they break the composability of the story, right? So if you use a query operator in your pipeline that does not return another iterator, then you cannot pipe it into an next seg that consumes an iterator. So out of this core design comes a weird sort of consequence that you have a table interface that is actually not about tables. So what do I mean by that? Or a different way to say this is, okay, so you're telling me that all of query does not operate on tables, it just operates on iterators. But I want to use this all the time to work with tabular data because that's an important type of data. Well, so we just use a convention here in Queryverse that a table is an iterator of named tuples. Okay? So that's, one way, that's sort of the core idea of how we represent tables. But note that we are not having a special interface for tables here. So we don't have a function like get a table or get rows or columns or anything like that. And that is sort of really crucial because that means that we can compose these different query operators into each other, and they can deal with tabular data even though they don't even know what a table is, because they only deal with tables. And that enables sort of a crazy amount of composition. So in fact, query itself, the package, if you look through the code, there's nowhere any place that it has anything table related. So it's not depending on a tabular interface. It doesn't know what a table is. It's just operating on iterators, and it happens to work well on iterators of named tuples. Okay, that's also actually a lie. There are a couple of important exceptions, but they're not core to the design of this. I think the exception here is that if we show the result of a query, we actually check, is it a table, and then we show it as a nice table. But that's the only place where the concept of a table actually shows up. So the core interface here is really that a table is just an iterator of named tuples. It's very minimal, it's very simple, it's very stable, there's nothing that can change here, it's well defined. And there's actually no code needed for that interface, right? So you can actually talk about this iterable tables interface without having a package for that interface, because the iterator interface is defined in base, and then you just say, okay, if you iterate named tuples, which are also defined in base, you have a table, right? So nothing is really needed for that. But it's not super convenient to use in many cases. Okay, so what do I mean by that? So if I'm a client and I want to consume the output of a query, I might not want to deal with iterators of named tuples. Maybe I just want a vector per column for the result of this query. And the way this is resolved in Queryverse is that we have a helper package called TableTraits. It has a function called create columns from iterable table, which admittedly is maybe not the best. I mean, it's very descriptive, but and you can pass it any source here. And if it's an iterable of named tuples, it will return you a columnar storage of that. And that code is actually not trivial to write, right? So I think Jacob has gone through this. I think a couple other people have gone through it. It's don't try. But there are other clients. For example, the time series types typically want to do other things, right? So they often, when they want to materialize things, if all the columns happen to be doubles, they want to actually materialize it into a matrix. Well, they cannot use this helper method here. They have to go through this by themselves. Other clients might just want to iterate rows, and they would go into this interface here at the end directly. And then there are other packages, for example, tables, that can also consume these. So the tables package can consume any iterator of named tuples, and you can access it with that API. So that sort of really increases interoperability in that space. But I have sort of, at least in the Queryverse world, there's a clear distinction between the interface, which is very, very, very minimal, and then code that helps you deal with that interface and makes it a little bit easier. And there's a separation of layers in Queryverse here. And I think that follows sort of the core design of iterators in base, right? So we have an interface which is just base iterate. Almost no one who consumes an iterator in base would use those functions. You would either use a for loop or collect, which are, helper APIs. You can think of that to consume these. And so that's sort of a similar story here that I use for Queryverse. Okay, so now let me tell you about something that, about a year or a year and a half ago sort of became clear. So there's this CSV Files package which loads CSV files. It uses text parse under the hood for the actual parsing. Text parse returns a vector per column of the parsed stuff. So it is already in a columnar storage. And then CSV Files iterates that as an iterator of named tuples, and so that's the connection to the rest of the Queryverse interface. So if I write a query like load foo CSV and then I filter it, that's great, right? Because here I actually, for the filter, I want to have an iterator of named tuples. But if I want to say load CSV file and then I want to pipe it directly into a data frame, then this is really super inefficient, right? So I get from text parse, I get everything as a columnar storage, and now I'm iterating named tuples to then collect it into another set of columnar storage here. So I have an unnecessary temporary allocation, and I'm going through this iterate, which is really just a waste of time. So one question I had at that point was, okay, how can I make this example really more efficient so that we can actually pass the data as a columnar data without breaking anything I've already have? And so the design I came up with is the following. And that's sort of the core of Queryverse here, is that you have this iterable tables interface. Every source has to implement that. And then we have lots of other interfaces that are optional and that are completely separate from this one here, that give you other ways to pass tabular data between a source and a sink. But it's not integrated at all, right? So this interface is completely separate. It could be defined in a separate package. And so I don't want to spend too much time on this, but one thing that has really worked out well here is that I can experiment and iterate quickly with new interfaces here and try them out, but I never break anything because everything can always fall back on this interface here. So I think this has really worked out nicely in the sense of super stable for 2 years, like nothing has ever broken, but at the same time I can experiment with new things. All right, so let me skip that. I think I should probably skip this one here also. Let me say one thing about the execution model. If you write a query like this one here, nothing actually is executed at that point. You just create the pipeline, the definition of the query. You can think of it as a query plan. And then only when you materialize or collect or loop over the query are things actually processed in query. So everything at that point is streamed and lazily computed. So this works well for large data sets. And this is especially nice for, I think this is the only example where this works right now, is for Feather, because for Feather, if you write down something like this, it will actually literally load each row, process each row, store it in the output, and then only start to load the next row from disk. So you get a completely streaming story here for this example. Okay, very quickly, big future ideas. Translate to SQL, that was my big one, but Brandon is taking care of that. It would be great to have a parallel backend for queries. The thing that I copied, the C# link framework, has a completely parallelized backend for queries, so I think we would just have to copy that. I'm really interested in full query plan optimizations and a column-based processing a la MonetDB. So those of you who are interested in database, scientific research literature, there's a lot we could do, and I think query could be a really good building block for that. And then this one, I actually have a prototype implementation of that. So all the processing that I've shown you with the default backend right now is based on iterators. So it's a pull model. The client says, give me the next row, give me the next row. There's a dual of an iterator where the source pushes rows. So it says, I have a new row, process it. And this is again copied from C#. You can adapt the whole query thing to work on these pushable or these observable sources. And so that's just something I'm also exploring right now. All right, I think I'll stop there. Thank you.
So we don't have that much time, but this is a good talk, so maybe let's just take like a few questions. Yeah? We asked the speaker to repeat the question.
All right.
So thank you for your talk and great ecosystem. I have a couple questions. What's the tables.jl and the iterable tables like? Are you gonna? Jacob said there's some unification efforts. Is that gonna? What's the story with that? The second question is, can you compose derived operators into not derived operators? And like as a third, like as a user, like can you make a package that says like I want to create a new derived operator and use that in the pipeline, and then without changing the core? And the third question is, what about like reshaping operations, like TDR, like kind of stuff, like reshape and stuff like that?
Okay. Okay, so let's start with the first one. I think, so Jacob and I have had a lot of exchange over the last couple of weeks, and I think we're both committed to making the tables and table traits, that's sort of the two packages right now, things operate even closer. Maybe we can even unify it. I'd be game. I don't think it helps to have multiple interfaces. I think where we are right now is actually in pretty good shape. I think it all works. It is maybe more complicated than it needs to be, but I think in terms of end user experience, we've actually worked out most of the kinks, and I think most tables, so I think sources from tables and table trades worked well together. I'd love to work together to make that even a more uniform story. The next question was, can you add new operators that are not defined in the core? So let me actually show you the slide I skipped. So these three new operators that we added are actually not what I call core operators, because they actually just reduce into a map call. Okay, so they just make it in a way simpler for you to do a projection. Adding those kinds of things is super simple, right? So you don't need to deal with us. If you want to add a query operator, though, that is a core query operator, so a query operator that you cannot express as the combination of existing query operators, that is more difficult, because other backends would have to add a method for that query operator, and they won't, if it probably, right? So I think that's sort of the distinction here. Reshaping operators. Thank you that you asked, because that reminds me that we added another thing during the last year, which I just forgot. So there's a gather macro. There is not the inverse of that, but we're working on that. But gather actually, I think it shipped, and I think it should work right now.
Thank you.
Ask a question. So for your database, you gave an example of SQLite. What about Postgres?
So right now, the work that Brandon is doing is specific to SQLite, because we just want to get something going, and SQLite is by far, setup is easy and it's easy to work with. I think the goal there is actually that so I think Brandon is so I hope I'm not saying things that Brandon is not working on right now, but that's my latest understanding of what he's doing. I think the goal is actually to take the query, translate it into an intermediate AST of a SQL query, and then translate that into actual SQL. And so for that second step of translating the sort of abstract SQL representation into a concrete dialect, that's, I think, where you could add translations into others, because there are always sort of some small differences between the SQL dialects. So that's, I think, where we would hope to add support for other database backends. That's certainly a goal, but I think right now we're just trying to get the SQLite thing off the ground and then add others, hopefully.
Let's thank the speaker